Can we tell how many people are in? We'll just give a few minutes for people to filter in.
Yeah.
For those of you waiting, we're just waiting for more people to filter in, and then we'll start soon. Okay, we're just going to wait a couple more minutes. We'll start at 11:05. Okay, we're just going to wait one more minute. Everyone that's filtering in, just about ready to start. Hopefully everyone can hear me. Okay. Seeing a thumbs up. Cool. Okay. Hi, everyone, and thank you for attending this online webinar about the Hawaii Climate Data Portal. The webinar is entitled Unlocking Hawaii's Climate Data. And we're going to basically just be talking about the tools, data access, and the future innovations that are coming down the way. We've had a lot of talks over the last couple of years as we've been developing this, talking about our methods, talking about how we're doing these kind of products and stuff like that, getting scientific input, getting feedback from people. And that's been really, really useful, but we feel like we really needed to be able to have a space and a place to show everyone what we've built so far and to get them familiarized with the platform and the different way that they can access the data. So that's the intended purpose of this webinar. I'd like to start by acknowledging our funders, the Hawaii EBSCOR, which is the current project is called Change Hawaii. And that is an NSF funded program that builds capacity at UH. And I'd also like to acknowledge now the EBSCOR team that's helping us put on this webinar. It's been really great to have their technical assistance for communicating and figuring out all the tech to be able to do that. I'd also like to acknowledge our partners at the East-West Center and people here at UH, including myself, is Hawaii Water Resource Research Center. So yeah, thank you. With that, we'll get started. Okay, so just real quick to introduce the team, the HCDP team. You have the basically the co-PI, so Dr. Ryan Longman, who's a PI and research fellow at the East-West Center, and Dr. Thomas Gianbaluca, who's a PI and the EBSCOR climate science lead. He's also the past director of the Water Resource Research Center, recently retired from that role, but still very much active in this work. And then you have the data and communication team. So that includes myself, Matthew Lucas, Dr. Carrie Kodama, who's a research fellow at the East-West Center, and Amy Schreibner, who is our research and communication person at UHWRC. And then finally, you have our cyber infrastructure team, which is at UHITS, and that includes Jared McLean, who is the software engineer developing the front end of the website, and Sean Cleveland, who's done a lot of the work with the backend data and being able to figure out how we store and serve up all this data. So this is the team. You'll be hearing from most of us today, and most of us are on the call too to answer questions going forward. So just real quick to go over the agenda. We're going to do the opening remarks. We're going to have a little presentation about the HCDP and the Hawaii Mesonet history. We're going to do a quick HCDP website tour. We're going to do a quick products tour. Then we're going to do some product deep dives into rainfall and air temperature and relative humidity. Then we'll reiterate how you can access data on the HCDP through what we're calling the threefold path to HCDP data access. Then we'll preview some new products that are going to be coming online in the coming year for the HCDP. And then we'll open it up for a Q&A session with an open discussion. And finally, we'll have a closing remark. And we'll also have an end of, at the end of the webinar, we'll have a brief survey. It'd be really great if you could fill that out. And if we have enough time and everyone fills it out, we can share the results really quickly up on the screen, hopefully. Okay, so just so that everyone knows where we're at, this is going to be kind of our guidepost through the whole thing. We are right here. So with that, we're moving to the Hawaii Mesonet intro and history, and I'm going to pass this along to Dr. Thomas Gianbaluca. Tom, go right ahead.
Hi, everyone. Let me get my slides up. Okay. You see that? And hopefully everybody can hear me. See some nods. Okay, so this will be a very brief history of how we got to this point, at least from my perspective. And really, when I think back on this, it starts from two opportunities that I was fortunate to have in my early career. This is in the 1980s. And I will talk briefly about those two things, starting with this, which is something that came out of some funding that I was able to get from a Department of Land and Natural Resources, Division of Water and Land Development, DOWALD, which you may not recognize because it doesn't exist anymore. It's something that eventually became the Water Commission. So that funding was provided for me to gather all the existing rainfall data that I could find, clean it up, identify the correct locations of the stations, correct data, find errors and so forth, and then use that data to develop mean and median maps of monthly and annual rainfall. So one map for, one mean map for January, one median map for January and so forth, and annual mean and median maps. And it came out in this paper report in 1986. And it really served as the main reference for Hawaiian rainfall for decades after that. So that production of that, the Rainfall Atlas was really, at that time, we saw it as part of a sequence, the endpoint of a sequence of efforts that had increasingly improved over over decades, going back to at least 1948, although there are maps even earlier than that. Most of these were statewide, even though I'm just showing Oahu here. But they got better and better as we got more data and methods improved and so forth. So that was a culmination in 1986. The other opportunity that really shaped what I did and what all this group is doing now started with another opportunity I had, which was some funding that I received from initially from the University of Hawaii, actually, intramural grant, a small intramural grant to study spatial patterns of evaporation across an elevation gradient. And so this is on Haleakala on Maui, and these three stations, 119, 106, 151, I installed those stations in June 1988, and they became the foundation of what eventually grew into a larger network that monitored and still does monitor the climate on the upper 2/3 of Haleakala. So that's a 10,000-foot mountain, 3,000-meter mountain, the upper 2/3 on the leeward side initially, and then eventually on the windward side and the south side as well. And so these stations were really transformational. The data that they provided supported research across a wide range of disciplines. And over time, we grew to really understand the value of this network and the data that came out of it. And it led us to start thinking about possibly having a larger network. And I'll get to that in a couple minutes. Here are some of the stations. These are fairly recent photos on the left of HoloNet stations. These are stations that have been maintained from as far back as 1988. We've updated and replaced the equipment over the years several times, but the stations have been maintained continuously. So we have continuous data for these stations with relatively few minor gaps in the data sets. At the same time, we also developed other networks. The one on the right, you see, I don't know if you can see there, but there's a tower in the forest, and that's an 80-foot tower in Hawaii Volcanoes National Park. And there's another 60-foot tower I don't have a photo of here handy. And so that formed a small network that we call HavoNet, and they're both in forest. One is in native forest, one is in forest invaded by strawberry guava. And in addition to that, we also installed a network called HipNet, which is a set of stations in windward Mauna Kea and leeward Hualalai. And most of these stations, in fact, are paired with ecosystem plots. So this network, monitors how climate variations affect changes in our ecosystems, our natural ecosystems. And that network is also still operating. So I think around 2008, DLNR contacted me and said, kind of asked if we're interested in updating the Rainfall Atlas. It had been, decades already. And so we went ahead with that, and using, a much larger data set and, advanced statistical methods, we produced a new Rainfall Atlas of Hawaii. And in this case, it was all digital. So we made digital high spatial resolution maps of mean or average monthly and annual rainfall. So a January map, February map, so forth, and an annual map. And we made it available on a website. So that website provided basic information, an interactive map that you could zoom in and click and get detailed information, and also provided data and images that could be downloaded. A little bit later, DLNR, and also I should say that the Army Corps of Engineers supported both the revised Rainfall Atlas and this new effort to produce maps of evapotranspiration for the state. So we did that completed this around 2014. And this ended up producing about 40 different maps or sets of maps for 40 different variables that we needed to estimate evapotranspiration. So that included air temperature, relative humidity, wind speed, solar radiation, net radiation, really a wide range of variables. And so we used that to produce 3 new websites, one for evapotranspiration, one for solar radiation, one for climate, which included all these different climate variables that we added, to the existing Rainfall Atlas of Hawaii website. Okay, now one thing about these products is that they're all static averages. There's no information about differences from year to year or month to month other than the average annual cycle. And so that led us to start thinking about making maps using the techniques that we had learned in making these climate maps, these average maps, and use them to make maps of individual periods. So Abby Fraser completed this set of the very first, what we call month-year maps in 2014, and it went from January 1920 to December 2012. And there's a high resolution spatial map of the entire state, not just Oahu, for this entire period, every single month between January 1920 and December 2012. A little bit later, Ryan Longman, who will talk in a few minutes, produced the first set of daily rainfall and temperature maps, and that spanned January 1st, 1990 to December 31st, 2014. So a huge number of maps, digital maps, high resolution, and really these resources provided something we never had before and spurred lots of research, allowed us to look at spatial patterns of the time trends, what areas are increasing, what areas are decreasing, what are the ups and downs in different areas and so forth. So we really saw the value of these. But one of the drawbacks is that these were done on projects that ended. And when the project ended, there were no new maps. And in fact, by the time the project ended, the newest maps were already a couple of years old. And so we started to think about what we could do about that. And that really led us to develop the Hawaii Climate Data Portal. And the idea was we wanted to kind of automate this process of, first of all, gathering the data, which is not a trivial matter. And we had gotten pretty good at that, but it was still an enormous chore every time we had a new project. And we knew that other people that didn't do this all the time, it would be much harder. So we wanted to find a way to gather and error check and gap fill the data out there, and then produce these gridded digital products and do it and automate that to the maximum extent that we could. And so that's really the idea behind the Hawaii Climate Data Portal. And you'll hear more about that from Maddie and Carrie. Okay, so one of the issues with the Hawaii Climate Data Portal is that the products that we produce are only as good as the data we have. And there are many, many weather stations out in the landscape, and they're operated by different entities and different organizations, different individuals, but there's never been any coordination among those different networks. And so the locations of the stations are not ideal. Many of the stations only measure rainfall or maybe only rainfall and temperature. Typically, they don't measure solar radiation, wind speed, and humidity, for example. And so we saw the need for a bigger network that's really more like HollyNet, but across the entire state. And so that led us to develop and seek funding for, and we finally did get funding for the Hawaii Mesonet, which is a statewide network of really high quality observing stations that produce data that are used for many things, but are also used for the work we do in Hawaii Climate Data Portal. And so here's a few sites and some of the stations that have been installed. And you can see they're across many different environments. So we're seeking to cover the entire state and all of, windward, leeward, sea level to the highest elevation, different environments. And all these stations are telemetered. The sensors are scanned once a second, and averages are taken every 5 minutes, and data are transmitted, usually by cellular transmission, every 15 minutes. So this gives us really up-to-date, real-time information across the entire state. We're still installing stations. We plan to have over 100. We're up to 56 at this point on 5 islands. We figure we're aiming to install another 50, hopefully within the next year. So I'm going to turn this next slide over to Ryan to kind of recap the history and fill in some of the details in the sequence that led to where we are now. So, Ryan?
Yeah, thanks, Tom. Happy to be here today to tell you guys about this work that's been spanning about 36 years now. Tom laid the groundwork here, but let me just kind of fill in a few pieces. Yeah, back in 1986, as Tom mentioned, I mean, I was in first grade, so I wasn't really involved in this at that point, but Tom was laying the groundwork for where we are today. He mentioned the HollyNet installation in the late 80s, and then these other networks, HipNet, HavoNet, and then a couple other ones spun by some PhD work for Shelley Crosby, Little HollyNet, and then Paul Krushelnicki, CraterNet stations in Haleakala Crater. So this whole period of time between 86 and 2012 was really this period of data processing, figuring out ways we were going to manually control, like quality control this data as it came in. It was more and more data and trying to figure out what we're going to do with it. Where we're going to store it. There was lots of different ideas on that. And it really, these questions started emerging, but we started figuring things out and kind of laying the groundwork for what's ahead. So then, as Tom mentioned, we started moving into this phase of product development where we started taking this data we had now and we updated the rainfall atlas. We had the ET climate products that were available, gridded, Abby's maps, the maps I produced. We did an inventory of data and started pulling all these data sources together. Started getting a little more sophisticated in our gap filling methods. The product development was coming good. And we started inventorying stations. So we were using the stations that we were maintaining, but also figuring out what else was out there, what else we could utilize, and what the quality of that data. And what emerged was this, people would ask us, oh, well, when are you going to update the rainfall maps? Or what, when are you going to have these daily rainfall maps? And, as Tom mentioned, the projects ended, but the folk, and then by the time you published it, you still, it was a couple of years out. So there was this constant need for more data. So the need for automation was it was clear and present, and we need to figure out how we're going to do that. Next. So when the EBSCOR opportunity came around, they came to us and said, hey, what do you guys want to do? And we knew exactly what we wanted to do. We said, we want to do this. And we're not able to do it because we don't have that cyber infrastructure power. We're climate scientists, we do data analysis, but we don't have that power to really put this together into a platform that has the sophistication that a computer programmer can do. So getting involved in the EBSCOR getting hooked up with Sean and Jared and folks at ITS that could help us, bridge that gap between not just having data, but making it available, accessible, and producing products in near real time. So we had a couple of years of development, and then in 2022 March we launched the HCDP. We basically had it working the day before and launched it the next day, and then we started publishing on some of our methods with Matt Lucas's work and Kerry Kodama's work, and then in early 2023 we were able to get some more EBSCOR funding to kind of take it to the next level. Next. And then the Mesonet came online in late 2023 in terms of, starting getting this really high quality data in. And we were able to substitute that for some of the other data that we were using. And then we were kind of moving into this period now where like, all right, we have this data, what can we do? And we started thinking about tools and resources, decision support tools, and then getting this data out to other folks that had needed it, right? So, we're coming from this period of building the cyber infrastructure to actually using the data, developing products, and then kind of getting the word out there to other folks because it is open source, the data is available to anybody. And now we're catching some wind of some folks and graduate students and folks that are using the data to kind of develop some tools and resources for everyone in Hawaii. So that's a snapshot, 36-year period. The important thing here, why this arrow takes us back, it takes us back to 1986 and, kind of laying that groundwork, getting those stations installed, making the first steps on mapping rainfall. And without those early steps, we would never be where we're at today. So it took 36 years to get here, and there's still a lot more work to be done. Yeah, so thanks. I'm going to actually share a screen here and show you guys a little bit about the HCDP, some of the web page here. It's going to be a quick tour because folks can come in and poke around as they please. But when we came into this project, we thought, okay, we want to make this simple, streamlined, folks to go and not know where the data is. So, you know, our big buttons here are access data, and Maddie and Carrie are going to talk about this a little later, but this is what actually gets you to the data, the mapping tools and the downloads and things. So I'm not going to go into that. Tom had mentioned the Mesonet. This is also kind of where the Mesonet information can be had. I have a couple tabs open here just to save time. You can learn about the Mesonet here. Then you can come onto this page here. You can get the stations. As the new stations come in, they get updated. You can get a station map here and then the list of stations, and then, you know, look at some of the data that way. The Pacific Portal, it's an ongoing unfunded project where we're, you know, thinking big picture here of where we can go with this. So we are developing a platform to kind of capture Pacific data, and we have country-specific pages, and we're linking to regional organizations and trying to expand the utility of the HCDP beyond Hawaii. We also have links to our resources here. Many folks that know the Rainfall Atlas, ET, and Climate Atlas products are currently down in terms of their interactive web interface. So what we do have these links available, and if you were to go to them, you can download the static products, right? So you don't have the interactive tool, but you can still get the data from the rainfall and then the ET and then climate stuff, the radiation, everything is here in that regard. We're also linking to Chris Schuler's American Samoa data portal, which is kind of an add-on to the HCDP. And we'll have some of the similar tools and resources as well as we develop rainfall maps for American Samoa. I just want to point out there is under the data portal here, you'll see the API access tab. And if you click on that, you'll be able to, you know, put in your information. And for you higher level users that want to actually go through the API and get the data that way, you can fill out this form, and then you'll get issued a token for you can access that data. We are conscious of the cultural resources tab. It's actually the most visited tab on the HCDP. So our Hawaii moon calendar is the most visited page on the HCDP. But this is something that we're continually trying to update, and we're always looking for ideas on how we can make this biocultural information improve the utility on that. We do have a searchable index here for all of the papers related to climate and ecology. You click on search publications, you can type in anything, you know, any topic you want or any author you want, and it will pull up from this library. And then finally, you know, we do have some research resources here, some highlights we're doing for research projects. If anyone's on the call that wants to highlight some of their research, we do have a research highlights page that, you know, we're always looking to update. So if you want to have a page dedicated to your research and it doesn't live anywhere else, please contact us and we can get that up there as well. And the last thing I'll mention, this is kind of supposed to be the quick tool link here, where as we develop these decision support tools and products, you can go to the climate tools page and then access them real quickly. So, you know, we have the Rainfall Atlas, our rangeland information portal, the climate portfolio tool, which will be coming online soon. And then, you know, things that other folks have developed, Chip Fletcher's sea level rise viewer and coastal erosion tool. And the idea is, you know, you keep this, you know, you keep HCDP bookmarked and you can just kind of access these things real easy. So in the same regard, it's a portal. You know, not all the data is going to exist here, but the idea of a portal, you go in one way and come out and get another. So if the data is not here, we want to direct folks to where the data is. So on that's a quick tour. You guys are welcome to poke around on here. If you have any suggestions or ideas or want to highlight your research or want to add a publication to the library, please feel free to reach out to us at hcdp@hawaii.edu. Thanks.
Okay, thank you, Ryan. Okay, I'm just going to share my screen here as I take it back. All right. So just to give everyone a bearing of where we are, Ryan just did the HCDP quick website tour, so we're going to do the quick product tour, and that falls on me. And before we do that, Ryan just did a really great job of showing you everything that's on the HCDP, but I'm just going to reiterate exactly what is the HCDP. It's the Hawaii Climate Data Portal. It's a web-based climate data access platform. It hosts and produces historical and near real-time high-resolution climate products for Hawaii. It offers data through interactive API and batch data requests. It hosts recent climate-related projects and publications. It's intended to be a one-stop shop for Hawaii climate data access. And it's pretty cool and it's free. I just wanted to stress that because that was the number one question when we were at the Hawaii Conservation Conference is this free? Of course it is. So that being said, let's just do a real quick tour of what's actually on the HCDP right now. So we have surfaces. These are map surfaces. They fill in between all points, or even if there's not points, they are a surface. So they are wall to wall. They are in GeoTIFF format. They cover the extent of each county. They're cut up into each county usually, and they are statewide. So if you want statewide, you can get that. If you want just Maui County, you can get Maui County. They're all 250 as of right now. They're all 250 meter resolution, and they all should nest within each other. And they're in the WGS 84 decimal degree coordinate system. Okay, we have station data. This station data is what is used to make these maps. Not all the products have station data because there's not stations for all of the products. I'll show you an example of that pretty quickly. But basically, if you are interested in station data, you don't want the surface, you can just get the station data. That's available daily and monthly. It's the same projection system. It comes down as CSV files. Okay, metadata. We're going to go into this later on, but basically, where we are able to, we make a metadata, our own custom metadata for every data product that's on here. It's tab delimited text file, and we do that so it's human readable, but it's also machine readable. So you can open it up and read something about the data without having to understand how an XML or understand some sort of federal government metadata actually works. So our metadata is our own creation, but it's really, really simple. And I'm going to be doing a walkthrough of that later. But just one thing to highlight, it does have leave one out cross-validation error metrics for every product when we're able to actually do that. So these are the products. Just a note on the actual products themselves, what they are. So we have Rainfall. That's daily and monthly. And the methodology, this whole webinar is not about web methodology, so we're just going to barely touch on it. We use a climate-aided kriging and climate-aided ordinary kriging to fill in the points between, or the values between all points. We have min and max, actually min, max, and mean air temperature. We have that daily and monthly, and that's basically a custom linear regression every day against elevation. So the relationship between temperature and elevation, and it's done and recalibrated and fitted every day. We have relative humidity, which is available daily, and that's a linear regression that involves dew point temperature and the daily max temperature. And Carrie can elaborate on that more in the Q&A if people want to know, but it was found to be the best way for us to actually create a relative humidity product. We also have NDVI, which is Normalized Difference Vegetation Index. It's a measurement of greenness. So it's basically how photosynthetically active is the land surface. And we are used right now, our product is derived from MODIS, and it's a 16-day composite, which is similar to the MODIS product. It's a little bit custom, but we are using a Google Earth Engine to process that product. And then we also have future climate projection. So we have future mean rainfall and temperature. For rainfall, we have wet season and dry season and annual. For temperature, we just have annual. There's two different methodologies and groups that created these, a statistical group and a dynamical group. They were both tasked with downscaling. They are both a reasonable understanding of what is going to happen, but they do differ. So it's good to understand both of them. Mid-century values are available for statistical. Late century values are available for statistical and dynamical, and they both have RCPs 4.5 and 8.5, which is basically us doing something with carbon emission, us doing nothing with carbon emission. So that being said, when you go to the HCDP to access data, the easiest way to get there is just click this access data button. And right now I'm going to do a live demo. So let's all hold our breath here. But basically, this is what the HCDP will look like when you drop on the page. The default is going to be the current month's monthly rainfall. So these are the data products here. You can always get back to these by clicking this data sets. We're in data sets right now. And you can flip through the different data sets here. So historical temperature, relative humidity, NDVI, and future climate projection. As we add more products on here, they will pop up on this top bar. When you go to this, there are sub-products. So for historical temperature, for example, there's maximum temperature, minimum temperature, mean temperature. For historical rainfall, there's rainfall, what we call rainfall. This is the current rainfall, and there's legacy rainfall. This is the data set that Abby Fraser created that Tom mentioned. So this one, it covers a further back, 1920 to 2012, but you can look at a January 1920 rainfall map on this portal right here. So if we did want to do that, say we want to switch data sets because we're in a different data set right now, I want to look at the legacy rainfall, you hit submit first. Then it will query and bring up the map, and you'll change the date right up here. Okay, that's taking a while. Oh, there we go. I think that happened. Oh yeah, it's December. So now if we want to change the date, we can just go back and find 1920. We'll do January. It'll automatically, the date will automatically change. And it'll pull up that January map. Okay, here's our January map. Let's say we wanted to zoom in. We can zoom in anywhere we like. We'll zoom into the Big Island. Okay, looking at the Big Island, if you float over anywhere, you will get a value. Okay, you can also press this screenshot map, and it'll do this little square thing, and then you notice up here, it'll automatically download a map. Let's see if that works. Yeah, so there's a map. This is a PNG map. We could take a look at it really quickly. So this is ready for a presentation, a report, anything like that. This is available for all of our different products. You can also, I'm going to go back to, this is an earlier map. This is a 2012. So I'm going back to the historical rainfall because the historical rainfall has station data on it. And I want to show you a feature with stations really quickly. Station data will have, if you click on a station, these are the dots, it'll tell you the name of the station ID, the latitude, and longitude. You can also then go to this location tab, and it'll tell you other stations that are on the map, which you can change to those stations by just clicking them. And then it'll tell you more metadata about that station itself. If we continue down, you go into time series, you can get a time series of that station's data. So there's a time series of that station data. This is daily rainfall values. This is monthly rainfall values. This is available for all the different products. So every product is going to have this functionality. Another functionality that's interesting is if you click not on a station, you can also get the data. This is the data from all the maps. So now we're looking at 30 years of daily and 30 years of monthly rainfall. If you want to zoom in on a plot, you can just drag and drop and zoom in on a plot. There's some pre-built ones like zoom to year, whatever else. You can hover over and get a value for any of this. You can also download this as a PNG. So you click this, it'll automatically download that. So now you have an image of this to also use in a presentation or report if you wanted to. Finally, the last thing, which we'll talk about again, but you can click download as CSV. If you click download as CSV, it'll automatically download this time series of monthly data or time series of daily data as a CSV right here. So it says virtual station, it has the latitude and longitude. So this is like GIS that you don't gotta do, okay? And as a GIS, starting as a GIS analyst, this is amazing. So going forward, that's the functionality of that feature right there. I just really quickly want to show you that, you know, some of these products have different, so relative humidity, it has station data on it, it's only available for a daily time set. And it's also going to have way more limited stations. Another functionality really quickly I wanted to show you is that you can change the base map. So we can change to USGS topo map, and we can also change the color here. So let's go for a USGS color ramp. Or we could do a street map, and we can do a turbo. Okay. You can also toggle off the data stations or toggle off the data map if you wanted to make a map with no surface or no station. So that is a quick tour of the products that are available on here. Oh, a note on NDVI, I'm sorry. NDVI, when you hit submit, it's going to go to the closest date. And as you can flick through dates of any of the products by clicking next. So when you click next, it's going to go to the next product that's available for that. And when you click this button over here, it'll go to the most recent product, or the most recent date. And if you click this button over here, it'll go to the first date in the data series. The future climates here are exactly what I said. You can select dynamical statistical. You can select the different RCP 8.5. You can select annual or wet for rainfall. For temperature, you don't have that option. And present day will get you basically a mean map, a current mean map. Mid-century or late century will get you late century. So if we hit that, it'll pop up a map. And there's display options for this. So this is one of the products has extra buttons here, but there's a display option. So you can do the absolute change, which is what it's loading right now, how many millimeters of change we're expecting to see in 2070 to 2099 using RCP 8.5. And you can change the units. You could also do percent change, which is going to be the same, but it's going to be scaled in percent. Or you could actually just look at the value. So if you click look at the value, it's going to change it. It's essentially going to be what the new mean is estimated to be using that methodology. It's really important, just a data note to always, if you're using these products, to always compare the statistical and the dynamical. There's no evidence that either one of them is better or worse. And so you have to compare both of them, and sometimes they don't agree, but that's just a little bit of a data caveat. Okay, so that being said, I am going to jump right back into the presentation here. And we did the live demo, survive that. So we're moving into the product deep dive, and I'm going to start it off with rainfall. So product deep dive rainfall, this is my AI generated image of a deep dive of rainfall for comic relief. And oops, sorry, getting stuck here. So to jump into rainfall, we'll go back to the rainfall, historical rainfall. I showed a lot of the functionality that's available here. We'll take a look at the daily product. So we're changing the product. We're going to hit submit. It's going to query up. It's doing the July 01 because that was the default map was in July, the monthly map. If we want to skip ahead to yesterday's rainfall, we can just hit this button right here. So this is August 21st rainfall. This is yesterday's rainfall that's on here. Again, like I said, you can change the map settings. You can do that. One thing is when you open up the daily right now, this is a experimental product. The reason we say experimental is we have seen a very low frequency of erroneous maps that produce values that are match the pattern, but maybe have a higher amplitude. So that being said, we want people to use this with caution. We're also kind of relying on our user groups to kind of highlight some of those things. We can't look at, there's over 44,000 maps in this data set. It goes back to 1990, daily rainfall, 1992 yesterday. So it's hard for us to keep track of every single map and tell it. We do that using a leave one out cross validation to try to sift through them, but it always helps to have eyes on them. So that being said, looks like yesterday's rainfall pattern for the Big Island was mostly a rainfall in the Kailua Kona area. So that coffee belt area was getting most of the rainfall. All right, so we're going to shift gears now and we're going to go to export data. Export data. Let's say that you wanted to get a batch of data, some of those surfaces. And before to get those, you would have to email Tom or Abby and or you'd have to email myself. And then you'd have to wait for me to give you the data and package it up and stuff like that. And you would get back a big blob of data. This streamlines it. You don't have to email anyone. You can go and you can select your data set. So all of the data sets are available here to select. We're going to just do rainfall. We're going to do monthly. You can do the time series. Right now, the default is basically all of it. So we will change it to, I'm just going to type it in here. We'll do 2024. So we're going to just do this year. So when we say expense, default is statewide. You could also get a county. So we'll just do a county. We'll get Kauai data as well. When you click the rainfall map, that's the rainfall surface as we talked about. But as you notice, this metadata and air metrics automatically, you have to take this if you're going to take any one of these products. It automatically throws it in with you. You can also say, I want station data. So if we click here, you get the station data. Otherwise, you don't get station data. Then you click add files. Now you have this here. If you wanted to do another one, say you wanted to get temperature at the same time, you could add historical temperature and do the same thing. Temperature map, add file. Now we have two of them. Okay. You can edit these files. You can or delete these files, delete the file sets. You can also add new ones, as I showed. You can put your email down. So if I put my email down, and I hit, you have to hit this agreement to our license and export data, you get this message, okay? Sometimes if you're asking for a small amount of data, you don't have to select the send download package to email. Sometimes it will just allow you to download it. But usually if you're getting multiple years and statewide domain, it will give you this message. So with that, we will jump back in. So this is where we are. We submitted our data request. Up to 4 hours later, we get an email. It's going to look something like this. As you notice, there's a hyperlink there where it says click here. When you click here, you will download a HCDP.zip. HCDP.zip, you extract that to wherever you want that file to be extracted, and you will see a file that's called HCDP data. So we're going to go into that file, and I'm going to walk you through everything that's in this download. Carrie's also going to do the same. I'm going to do so from the Windows perspective. Carrie will do so from the Mac perspective. Also, Carrie's going to be using a different product, so you'll see some nuances and difference there. So we're inside right now. The file tree is up on the top. What you're actually looking at in the file is right here. As you can see, the first thing that's inside there is the license and the rainfall. So we're in the HCDP data directory right now. So what is the license? The license is basically Creative Commons legalese that says you need to give credit. As scientists, we like to have credit. We really like to have citations for our work, but mostly it says you can't profit off this data without coming to agreement with us. And that would, by us, that would probably be UH. They don't allow us to actually negotiate on this stuff. So this is the actual license. It also says no derivatives. What it means by no derivatives is if you're going to take our data, create it into something else, and then sell that to somebody else, you have to come to an agreement with us. That's just a little bit of legalese we put in there. Other than that, if you're using it for non-commercial purposes, like publishing or doing a project or your day-to-day use, go for it. Go right ahead. Okay, back to what's in here. We're going to click inside. We're going to go into the data product, which in this case is rainfall. So we're going to click inside of the rainfall. We get a sub-product. For rainfall, it's called new because we were selecting the current rainfall. If we would have selected Abby's rainfall, it would have said legacy. But this is the sub-product. If you click into sub-product, you get time step. Because we chose monthly data, it'll have monthly. If we chose monthly data and daily data, it would say month, it would say day there. Once you go into the time step, you get the regional extent. Because we selected Kauai and statewide, we have Kauai and statewide. We're going to go into the Kauai folder. Okay, once we're in the Kauai folder, now we're looking at data types. So we're looking at ANOM, ANOM SE, data map, metadata, and SE. SE stands for standard error. So we can see that there's this tiered system in there. Okay, note, station data, which is called partial, is only going to be present in a statewide extent. As of right now, we don't cut up the station data to the county domains. That hasn't really been a priority of ours, but just so you know, if we would have gone into that statewide, there'd be an additional folder here that would be partial. That's where your station data is. Other than that, it's going to follow this exact same format. Okay, so we went into the data map. Once we get into the data map, we get a folder that is called year. You can see inside the folder, there's something there. Note, if we, you can put multiple years in one download. So if we would have chose December, January of 2 different years, we would have 23, 24 right here. Okay, once we're in there, these are the files that we have. So this says rainfall new month Kauai data map 2024-01 through 07. Note, other time steps may have a directory above this. So if the data is daily data, it will have a monthly folder above this. And I think Carrie shows that in her example. Okay, so these products, this is our January, February, March, April, May, June, and July maps. So these are all of our maps that we have in here that we got. So just to expand all of this, so we can actually talk about what these are. We already looked at the data maps. This is your rainfall, what you're looking at. We also have the anomaly maps. So what the anomaly maps, which are called ANOM, those are the fractional difference between the mean monthly map and the data map, the rainfall in millimeters. So this is essentially a 1 month anomaly, a fractional anomaly. So you can see that on Kauai, it never reaches 1. So this was a slightly drier than normal July, with the driest portion being in the Waimea Valley and the wettest portion being in the Nepali and Honolulu areas, where they almost reach a normal amount of rainfall for the month. This can be a really useful data map if you want to understand how dry or wet your current month was. Okay. We also have the standard error. So this is a standard error of the rainfall prediction itself. So as you can see, there's some dots. Those are kind of artifacts of where the station is. That's because standard error increases as we get further away from the station. But it's not perfect as far as linked to stations. But this will kind of tell you how much error over space there is. Finally, we have the standard error of the anomaly. So this really shows the stations, and that's because when we're basically cragging to find the anomaly and then converting it back to the rainfall. So that being said, you can see where all those stations are, and you can see how that error really increases going away from the station. Okay, and then finally, we have the metadata. So here's the metadata. When you open up the metadata, if you were to actually look at the metadata, which most people don't, you'll see that there's this top block of text. Okay, we're going to zoom in on the top block of text. First thing, that is the header. The attribute is one column, the value is another column. We have a data statement here, which is a human readable data statement. It's dynamic in the sense that for the monthly rainfall, it uses R squared to basically say qualitatively how good this map is. Okay, next, there's a big block of text that has the extent, and then it has the month, year of the map, the start date, the end date. But I wanted to highlight this row right here, data produced. As you notice, this data was actually produced on 8/19. That's because we had an error with our July map and we had to rerun it. So this is a really important row to look at. If you want to make sure, if you downloaded data, say a year ago to do an analysis, and now you're like, I'm just going to redo that. I'm going to do another analysis with that data I already downloaded. You might want to download some of that data to check the metadata, because if we updated it, this is how you'll tell we updated it. Also, there's data version type. Right now, we're only producing a preliminary version of data, but as we create more data ingestion, we're going to have, there's data that has latency in showing up, and we're going to have that data. We're going to have different products that are different versions that are including more data. Right now it's all preliminary, but there will probably be an operational and an archival product that will come out 3 or months or a year after the initial preliminary data comes out. And that will replace this. You'll always be downloading from the portal. You'll always be downloading the most current data. Okay, finally, we get to the error metrics. So the stuff at the top has to do with like some kriging stuff. The main thing you want to look at if you're interested is the actual error metrics here. So this one had an R squared of 0.955. It had a pretty decent RMSE, which is root mean squared error, and it had a really low negative bias. So a quick excursion. All of these are derived using a leave one out cross validation. That is where we do a cross validation for every single point that is used in the map using the process we use to make a map. So a quick excursion into leave one out cross validation. If we have a point and we observe a certain amount of rainfall, in this case of around 100 millimeters, and then we omit that point and we make the map, and then we extract the value on the map, that gives us our predicted rainfall. So we predicted a little bit more than what the observed rainfall. And if you add a one-to-one line, any points that falls on this line is a perfect match. And it's that difference between where that point is and where that one-to-one line that will generate our error metrics. So if you add another point, you add a third point, eventually you add all the points, you can calculate these R squared, root mean error, squared error, mean absolute error, and bias. And each one of these error metrics have their own benefit. And I'm not going to go into what each benefit is used, but you should research that yourself. Finally, we can also look at the linear fit. So this red line is the linear fit that produced that 0.96 R squared. So you can see that we almost have a perfect fit, which is why we would say this is a great map. I'd also like to say that, just to reiterate, cross-validation is already done for every map when possible. And I'd finally like to say, read the metadata. Okay, the last thing on the metadata is going to be this credit. So the credits is going to have, who worked on it, what grant supplied it, and it's going to have some contact information. For the rainfall, the contact information is myself, Ryan, and Thomas, and our emails are right in there. So if you want to email me, read the metadata. Okay, so back to our roadmap. We are still in product deep dives. We're in air temperature and relative humidity. So I'm just going to leave this right here. This is a product deep dive for air temperature, and I'm going to stop sharing my screen and pass it over to Carrie.
All right, I'm going to share my screen next. Okay, so the temperature and relative humidity products function, they'll look pretty similar to the rainfall that Maddie just went into a great deep dive on. So I'm going to just highlight a few of the little nuances that make them different. So first, for temperature, the subproducts available for that are going to be the maximum, minimum, and mean temperature. And these are all available both daily and monthly. I'm going to quickly switch to daily maximum temperature just to have the map up for you to see. And then relative humidity has no subproducts. It's just a standalone, and it only has daily data available. And just an important note for the daily, this is not an average of the 24-hour average daily. This is just the 1 p.m. average value of relative humidity, because when we were developing this product, it was specifically designed for utility and wildfire risk modeling. So that's why that time point was chosen. So another nuance is that minimum and maximum temperature also have station data available, which you can see by zooming in a little bit on the map. You see the station points. But if we switch to mean temperature, you'll notice that that option is not available in the visualizer. And if you change to that map, it does not have the station data. And that the reason for that is because the mean temperature is derived from the maximum and minimum temperature gridded products, not from their own station data products. And similarly to the rainfall, you can, select a location on the map and get time series data. Looks like there's a weird one over there. But you can, again, download as a CSV, both daily and monthly where it's available, or just daily for relative humidity, and take screenshots of these plots and adjust them as you see fit. Oops. So if you were to download the data using the batch export process that Maddie showed earlier, you'll get an email that gives you a download link, and you can download the zip file. And in this case, I've downloaded both relative humidity and temperature. So those would be the data products that you see in the first layer, in addition to the license file that Maddie showed. So if you unzip those folders and try to navigate through them, again, you'll see that you'll be able to choose between whichever data products you downloaded, and then that'll take you to the subproduct folder if that's applicable. So in the case of temperature, you'd see maximum and minimum, which I've downloaded. And if you downloaded the mean, you'd also see a mean option. Relative humidity has no subproduct, so it would skip over to the next subfolder, which would be the time step. So daily or monthly, or daily in the case of relative humidity. Choosing one of those, that would allow you to select your regional extent. For this example, I downloaded both just Kauai and also statewide. And so you can choose whether to open the data files for the individual county or the entire state. And then opening those would give you the following options. So you'd see data map, metadata, partial, and SE, and I'll reiterate what those represent shortly. So this is a little different from the rainfall because rainfall had the anomaly maps as well. We don't have anomaly maps for temperature and relative humidity. So you would just see the actual data product and then the station data and metadata. So if you click any of those, again, you would be able to navigate to the data using the time points. So you would be able to choose which year to get the data from. If you downloaded multiple years, you would see the other year options, and then whichever months you selected, or it would just be by year if you downloaded monthly data. So selecting through the subfolders, you would get either the daily data for each given month, or you'd get all the monthly data for each given year. And the file naming conventions just follow the subfolder structure where you would have the data product and subproduct, followed by the time step, regional extent, and then the data file type, and then the date of the data, and then whatever file extension it is. So again, the maps are in .tiff geotiff format, and then station data are CSV tables, and the metadata are tab delimited plain text files. So these file type labels might be a little mysterious to you. So just to define what each of them are so you know what you're looking for in the data folder. Data map is going to be the actual gridded product that you're probably looking for. So for example, this is the data map for maximum temperature, and you can see the example that I downloaded for the 1st of August. And this is what the file structure would look like. And so, yeah, this is just a plot of the actual gridded maximum temperature for this day. And then the other map type would be called SE. So what that refers to is the standard error, and that's just a gridded map of the spatial uncertainty that corresponds to each location on the data map. So like for each day, you would have the data map produced and then a corresponding standard error map that's also produced. And that just tells you at each grid point how uncertain the methodology was at that location. Then there's partial, which refers to partially gap-filled station data. And again, with temperature and relative humidity, this is a little different from the options that you would see with rainfall, because rainfall offers both unfilled and partial filled. So we only have partial filled for temperature and humidity. And that just refers to quality controlled outlier filtered data that have certain stations gap filled in. And what you'll see when you download it is a CSV table where there is a number of metadata header column labels, and then that's followed by the actual data points for each day or month in the time series that you downloaded. And so some header notes, these are just individual station identifiers and information that might be useful to you. So SKN would be the state key number, and that's just a unique ID that we use to index the stations in our process. Then station information like the name, the observer group, and the network that provides it. And then what island it's on, its elevation, latitude, and longitude, and then a number of unique identifiers that we use to fetch the data from different database sources. And then just note that the data columns are marked in this format where there's a capital X and then dot year, dot month, dot day. So that's just our special date formatting if you're ever trying to do date indexing when you're doing data analysis. And then just to go back into the metadata again, just reiterating a lot of the things that Maddie talked about, just to make sure that you'll never forget it. But so we have this machine and human readable plain text file. And again, there's the attribute column on the left and then the actual values on the right. I've just redacted the data statement because Maddie did a good job going through what that says. It says pretty much the same thing for the temperature and relative humidity as it does for rainfall. And so you'll see information about when the data were produced and versioning. So like we're still in preliminary right now. And then names of relevant files, information like fill value. So like what the missing value that we've chosen to fill in the blank spaces around the map would be. And then information about the georeference system. So if you're doing any GIS work, you'll know what projection that you're in, and resolution and extent information. And then continuing towards the bottom, there will be uncertainty metrics. So in the statewide metadata, you'll get both the uncertainty for each individual county, and then you'll also get a global uncertainty for the entire state. If you just downloaded a county-specific metadata, then you would only get the individual county values. And then again, credit statement and the award number for the grant that we used that supported us, and contact information for whoever developed that data set. So turning it over back to Maddie for recap of data access.
Great. Okay. Okay. Everyone can see my presentation, right? Yep. Okay. So Carrie just did a great job with the deep dive. Now we're going to reiterate how you can get data, because you learn by repetition. So this is going to be repetitive, but we're also going to show you the third way to get data. So we are calling this section the threefold path to HCDP data access. And the first path is interactive point data. So to get this, you go into the HCDP, click access data, you click visualize data, you have your map, you zoom in on your location, maybe you change your data set, your time period, your date, you submit all of that, you click on a point, you get a value for that point, and then you click on time series data, down at the bottom, time series. It's on the far right-hand side. Once you get to time series, you'll see the daily data. We can zoom, we can scroll down, we can get the monthly data. And if you want to download the time series of that location, you click download as CSV, okay? This is really good for point. You can also do this for station data. So station data, once you do that, you'll automatically have a download of CSV that shows up there. And this is delivered like a golden scroll, okay? So there it is. All right, the second way to do this is export batch data. Okay, instead of going to visualize data, we're going to go to the export data tab. You can also go to this if you're in the visualize data part on the far left-hand side. It will bump back out and you can go to export data. But export data, We're going to select our data set, select monthly or daily, select our time frame, select our extent, select our products, just grab them all. We're going to hit apply. You can edit that file set. You can delete that file set. You can add another file set. You can put in your email. You can have it download. You can hit export items. It will give you this message. This is that same tired joke I showed earlier. You'll get an email. There's your data. You extract it. You can go through the file, the folder structure that Carrie and I both walked through. Okay, that's the second way. The third and final way is the API code access. So for this, I'm gonna leave it to Jared. Jared, go ahead.
Thanks. Okay, so all of the functions available through the HCDP are also available through the API. That's how it retrieves all of the data through the HCDP API. So to get access to the API, you will need access tokens. So Matt had showed the form for requesting that. So I'm just going to walk through a Python notebook. You could access the API from any programming language you want or just through Bash. But yeah, this is a Python notebook demonstrating some of the functionality. Yeah, so anytime, this is the core API URL, api.hcdp.eky.org. And anytime you make a request to it, you'll want to add this header, which just has the authorization, bearer, and then your access token. So run the cell, that'll just construct the header that's needed, and then the base URL. And then your email address will be used for certain requests, mainly downloading data packages. So this just basically creates a function that will pull back the raster from the raster endpoint, which is pulling back the data maps. So this will basically give it a set of parameters. So all of the data sets are parameterized for identification. And then it'll submit a request to the API, given those parameters to the raster endpoint, and it'll pull back that data map. And then this just has some logic for plotting it to a map in Python, so using Plotly. So if I run this, so there's 3 different maps that's going to pull back. So the first one is temperature, and then aggregation, max temperature for the time period day. This is doing it for yesterday's date. And then the extent is statewide. Rainfall will do something similar, but this is going to be the monthly map for last month, and this is going to limit the extent to Oahu. And relative humidity, same thing, yesterday's daily map for the Big Island. So all of the data sets are parameterized for identification in the API. Then see that it, so these are the actual request URLs. So it kind of appends the parameterized data sets onto the base URL of the API URL. And then, yeah, these are the maps that pulled back. So these are the diffs and just small visualization of them. So the next thing that I'm going to show is having coordinate stations. So it's a similar process, and we're using the stations endpoint. So this is going to create a JSON-based query. So this is on the back end, it's backed by MongoDB, so it's going to be a Mongo-style query that we're constructing. So this is going to pull the metadata, which are stored in separate documents for efficiency. So you can pull a set of metadata, combine it with the actual station data, and then you can plot them on a map. All the metadata has geographical locations for the stations. So this example will pull the rainfall data, the monthly rainfall data, using partial fill. So this has the extra parameter fill type. There we have filled and unfilled data. And then this is going to be for last month, and it's going to construct a map with all the using the station metadata. and plot all of the values on the map. So this is similar to how the HCDP constructs map, except this is now in Python. And then this is the virtual station. So a similar thing where instead of getting for the actual, oh, sorry, I'm getting ahead of myself. This is just going to create a time series of a specific station. So this was one specific, the monthly time series, or sorry, the monthly station values for last month. This is going to create a time series of the stations. So this is for a specific station. I think it's just grabbing whatever the first station ID is as an example. So this is going to be for station with SGAN 781.12. And this is getting the last year of daily rainfall. So you use this greater than or equals to tag, and then give it string for last year. And it's going to pull back the last year of data and then plot it on this graph. And here's the example of the API call for that. And then this is going to be maximum temperature data. So this is a virtual station. So we're providing it with, so this is the raster time series endpoint, which is for any location on the map. And this is providing with a latitude and longitude. There's a couple other ways that you can do it. You can also provide a row and column if you know the specific grid cell you want on the map, but this is for a specific geographical location. If you submit that, this will create a time series for the last year of maximum temperature data at that specific latitude and longitude. And then these are examples of the data download API calls. So this is basically, we're constructing, this is on the back end how it constructs the JSON, like how it identifies what data you want. So similar to filling out that form and finding it that way, this is just basically a JSON representation of that. So this is daily relative humidity data for yesterday, statewide extent, or that's actually not supposed to be there, sorry. So range is, so start and end date. So this is 1 year of data, partial filled, and then this is going to bring back the station data. The grid map products have slightly different variables. So this is in a separate object. So this is going to be the data map and metadata. You can add in standard error map, all that. Yeah, same main parameters except without fill type. You can add other data sets to that to pull it all back in one data set. So this is, yeah, this is where the email is used. You put in email, the data set that you want, and then it will take this. And this is an instant download thing. So this is a relatively small data set. So it should somewhat quickly pull back the download data, and this will just save it to a file called data.zip. And it'll take a few seconds, but this will pull it back immediately. And running this in Google Colab, so it's not, if you run it locally, it would download to your local machine. This will download to just the file system that's backing this. So once it finishes doing that, so basically what's going to happen is it's going to sends off a request. It returns a link basically for grabbing that data. And it said that it wrote it to the file. There we go. Okay, so now it's been downloaded. So this is the data with that. I'm not sure, I might have to download this to actually show you, but it's the same functionality as the HCDP site. So yeah, this is the data package. And then this is same thing, except this will send it to your email. So this will return immediately and just say that it's generating download package. And whenever it completes, it'll send an email to the email that you put in with the data. So that's just a basic overview of some of the functionality. We have documentation with all the different endpoints and all the different functions that you can do. But this is, yeah, a quick overview of it. But any of the functions available in the HCDP are all go through the API. So anything that you can do on the web app, it can be done via the API and more. So.
Great, thank you, Jared. Okay, we'll just moving along here. Back to our roadmap. We're now on to coming soon, some new climate products in development. Sorry. Okay, so coming soon, some new products. We have on the left-hand side, wind. So the very top one is actually a max daily. There's also mean daily wind speed. That will be a product that should be coming out pretty soon. But part of that product is actually hourly gridded speed and direction. This data we will not be putting on the front end, the HCDP front end. But we will have it the API access. So if there's something you really want to do with hourly wind, you'll have to learn how to use the API to be able to retrieve or extract information from that data. Also, another product that's going to be coming up pretty soon is solar radiation. So we're going to have the near real-time full solar suite, and we've been working with Peter Sadowski at UH to develop that from satellite observations. And that should be coming out pretty soon as well. Another product we want to say, moving into the kind of more decision support tool, kind of derived products, we're probably going to come out with some drought products. And we'll probably start with standard precipitation index, or SPI. There was a data set of SPI that was published off of Abby's data that I published some time ago. We'll probably host those on there, and we'll probably also make a near real-time SPI product. And there's multiple time steps for that, but I don't have time to go into that. But that'll be a really great one for drought, because that's used a lot for drought. Finally, we'll move on to fire risk. There's 2 fire risk products that are going to be coming out pretty soon. And that will be a monthly fire probability. So this is basically using monthly data, and it's using past monthly data to be able to try to understand what fire risk is over time. And that'll go back as far back as our monthly data goes back. So this will be really good for understanding fire risk over time. Finally, we're going to be doing daily ignition probability, so the chance that an ignition could occur. And then that is going to lead into a chance that a large fire or a fire over 8 acres is going to occur. And you can see examples of those 2 maps right there. So those will be coming out near real time too. And the timeline for these is we expect these products, wind and the monthly fire probabilities, to hopefully be done by the end of the year and up on the HCDP. And we expect these other products to probably be in early 2025, hopefully. Okay, just another product and application that will be available is the automated climate portfolio tool. This is a really cool tool that takes all the data from the HCDP and it automatically makes a 40-page plus site-specific climate information. So this is an example of using an ahupua'a in Waimea, Waikoloa. Anyone can make it. So again, this is like bringing GIS functionality to anyone who wants to do it. You can choose or draw an area of interest. And it includes yesterday's data. And this should be out by hopefully the end of the year, December of this year. One thing this product is really good for if you're going to have roundtable discussions about a site. It puts it in plain language with a bunch of figures already made. So it's a great talking point for having meetings about that. Okay, finally, I did want to highlight that we are going to have some new climatology products coming out. And that will be, we're going to call that contemporary climatology, I think. And that is going to be, the data is going to be based off of 1990 to 2020. And that's going to be like new mean monthly maps. So this is going to replace the original rainfall atlas, or the last iteration of the rainfall atlas, not replace it, but augment it. And it's going to be based off of data from 1990 to 2020. And we're going to have rainfall, air temperature, relative humidity. We'll probably do mean monthly maps and mean annual maps for those. That's going to be coming very soon. That is, the data is already created. We need to host it up in there. We're hoping to have it done by the end of next month. Okay, Also, we're going to host, as many of you maybe learned, the Climate Atlas and the ET Atlas and the Rainfall Atlas are no longer functional from their URLs. We've ported that data download feature over, and Ryan showed you where that is on the HCDP. But I do want to say that we're going to eventually make that data interactive. Not all of the data, but the mean monthlies and mean annual products will be on the HCDP. Again, that data basis period is a little earlier, and it will have rainfall, air temperature, relative humidity, wind speed, solar radiation, net radiation, downward, so on and so forth. Everything that was on the ET Atlas and the Climate Atlas of Hawaii will be on there and be able to be interactive and downloadable and all of the functionality of the HCDP. That's going to be hopefully coming by the end of the year. Okay, so with that, we come to the questions. We have a little bit of time for question. I know some questions were in there. So again, here's my obligatory AI generated image. And I put my email down here, but if you really want to get my email, read the metadata, okay? And with that, we can open up. I saw some questions that were on the feed. Maybe you can answer some of these, rapidly answer some of these. I'm going to go to the top right now. Scott from the state of Hawaii, do you know if there's any, have been talking to the National Weather Service about getting all this data compiled so we can get NFDRS forecast for fire planning and preparedness? We've definitely been talking to National Weather Service. I don't know if we've been talking to the right people for that those exact products, but if that's a particular forecast or product that you want to see, maybe shoot us an email so you can connect us with the right people. Also, oh, sorry, this web poll just posted up here. That's because we don't want people to leave. So please go ahead and answer this poll really quick. It's going to have questions on here that just to help us collect information of how useful everything was to us. And if everyone can answer this poll, then we might be able to share it, or we can email it out to all of those that signed up. So thanks. Let me just go back to the questions. There's a question about licensing. Yeah, as long as you cite it, Ken. The question was about derivatives. Yeah, you can use it. That's research. Use it in research. Erica, yes, it's Modus. We do apply a cloud mask. It isn't perfect.
We should say real quickly, Maddie, that we do require, we do make everything available for free as long as it's a non-commercial use.
Yes.
If you have something you're going to sell, then you need to talk to us.
Yep. Data be using grant applications. Absolutely. Maybe try to include us if possible. Have you guys considered using NetCDF, ZAR, VS Red's data server? I'm going to leave that one to Jared. That's a little bit outside. We could probably make a functionality down the line that allows you to bin up your data into a NetCDF. But as of right now, we chose GeoTIFF because it services the most amount of users. Yes, there's API access. Okay, what is the plan for the interactive map becomes live? The older tool is never going to be available again. Well, I shouldn't say never. We're hoping to develop that tool over the course of a year. The functionality of that tool will probably take us over a year to recreate because we're going to have to code it from scratch. You can blame Esri for that. It was a proprietary program that they had that they stopped maintaining, and there was too many security patches for us to keep it going. Monthly temperature, that looks like a case specific. How long does the precipitation take? Everything should happen the next day, but sometimes we get hung up. Okay, it looks like somebody, okay, so we have some HCDP polls. We have the poll results here. I'll just show those. Okay, looks like the poll was closed early, but, oh, nope, it's still happening right now. Great, 39 recipients. Those of you, it looks like public employee was a majority. Fog drip, any plans for fog drip data? Yes, Tom has a postdoc working on that on. And Tom, is that going to become a product, you think?
We certainly hope so. We're working towards making, spatial estimates of the patterns of cloud water interception. Yes. That's the goal.
Great. Okay, we still have participants taking the poll. Had used, most people had, but only 2/3. Great, nobody said it was not useful at all. Most of you said very useful. Everybody learned a new feature, that's amazing. And most are very likely to use it. Pretty even split about how they're going to be using the HCDP. Again, we have a long answer there. This is great. Thank you so much, everybody. Do we have another question here? We're kind of over time, but I'll take a couple more questions. The Jupyter Notebook. Email hcdp@hawaii.edu and Jared could probably send you the Jupyter Notebook. Is that correct, Jared?
Yeah, I can do that. It's on GitHub, so it's publicly available.
Okay. Maybe we'll think about putting that GitHub link on the HCDP itself. That probably would be smart. Okay, cool. Thanks, Chris. Will data for other Pacific Islands be available, Guam, Saipan? The hope is yes. I believe Carrie is working. Ryan's answering that right now. But Carrie, you're working on some of that, hopefully?
American Samoa, yes.
We're starting with American Samoa. But I think the hope is to go as much of the Pacific as we can get data for. It's pretty data sparse down there. So it might take us rethinking some methodologies to be able to create this stuff.
So Maddie, let me jump in. We're going to be doing daily rainfall mapping for American Samoa and Guam. We're going to start on that this next month, using some of the methods that Maddie developed. And then what we're doing is we're going to have those available for visualization and download in the same capacity that the Hawaii stuff is available. So starting American Samoa and Guam, and as proposals get written and funded, we'll try to expand that to other areas of the US API, if not the greater Pacific.
Okay. Chris says, is there a routine available to capture late arriving data or any data that has been reprocessed? So that touches on that data versioning that I was talking about. Right now, we are only making preliminary versioning. So that means if the data wasn't available at the end of the time step, or the data, whatever data was available at the end of the time step, it gets used in creating the product. We envision making a second tier product that maybe we call operational. That would happen 2 to 3 months after the time step ends. And that would allow us to grab other data that is human read and filters through other data portals and other data streams, as well as potentially including USGS, I know, corrects their data a couple months afterwards. And so this would allow us to use the corrected USGS data that's in there. But our focus was to be able to make a near real-time product. And so to be able to make a near real-time product, we have to accept that there's going to be a certain amount of errors. But the idea is that, yes, we will make these second-tier products, and that as soon as those second-tier products come out on the HCDP, they'll replace the older products. And how you can know what product you're looking at is by checking the metadata. Okay, I think we're a little bit over. Will American Samoa data include data measured specifically from Manus Island? I don't know. I think that we'll have to save that question until we actually start working on the American Samoa. So, yeah. Okay. I am going to close this. I'm going to end the poll. And I'm going to close that. And I'm just going to, whoops. There's the poll results for everyone. Okay. And I'd like to actually close out and say thank you for everyone that came. The link to the HCDP is right here. So Hawaii Content Data Portal. If there's any general questions, or you find a bad map or some missing data or a station in the wrong location or something like that, you can email hcdp@hawaii.edu. Also, there's a link there for the EBSCOR Change Hawaii project. We're part of a larger project that's doing a lot of really cool data work. some of their products will probably end up on the HCDP. A lot of our products will probably end up in their methodology. So go check out what that's doing. Thanks again to Hawaii EBSCOR. Thank you to NSF. Thank you to University of Hawaii East-West Center and Hawaii WRC. And feel free to reach out to us. Thank you so much. Okay.